And my name is Thomas Fong, and I'm the president of the SSA New South Wales branch. And on behalf of the branch, thank you everyone for joining us for this branch meeting. And I hope everyone is staying safe while enjoying the new, the freedom and the new normal. And we'll begin a formal part of the event with acknowledgement of the country. In the spirit of reconciliation, the Statistical Society of Australia acknowledges the traditional custodian of country through Australia and the connection to land, sea, and community. We pay our respects to the elders past and present and extend the respect to all Aboriginal and Torres Strait Islanders people today. And it's my absolute pleasure to introduce tonight's speakers, distinguished Professor Matt Wong of UTS Sydney. And before joining UTS, Matt has held faculty appointments from Harvard, Rice, Texas A&M, UNSW, and University of Wollongong as well. And Matt has also received multiple awards, including the Moran and Hannon Medals from the Australian Academy of Science, as well as the Stat Society highest honors, the Pittman Medal. And as a trivia, after 23 years of working in the Sydney region, this is apparently going to be Matt's first talk at the New South Wales branch meeting. Well, if you don't count the Lancaster lectures as a normal event, then there will be Matt's first seminar for us. And tonight, Matt will give a talk that on the topic that I deeply care about is on software dissemination. And Matt, the floor is yours.
All right, thanks, Thomas. Yeah, so I'm going to start talking about statistical methodology for about the first 10 or 15 minutes, and then we'll get into the main part on software dissemination. All right. All right. So we're going to start with a statistical methodology problem, which I've been working on with one of my students for about the last year. And we chose it because I saw that there was room for improvement, especially when it comes to scalability for very large versions of the problem. And the problem is called generalized additive model selection. And if you want to find out more about it, then it's in this book that came out 3 years ago. That's a must-have for every statistician and data analyst in the world. And by writing this book during the 2010s with my co-authors, I learned a lot more about generalized additive model selection than I knew about before. I knew a lot about generalized additive models, but the selection part is something that I'm fairly new to. So the project is with my student, Virginia He, and we're building on a paper by Trevor Hastie and one of his former students. And Hastie is one of the fathers of generalized additive models. And so we read his paper that came out in 2015. And that paper is non-Bayesian. And we've been able to see how if we couch it into a Bayesian framework and use methods such as Markov chain Monte Carlo and mean field variational Bayes, we can do quite well in terms of achieving various goals associated with this problem. So I'm just going to give one example. And so this is a spreadsheet that has about 2,400 rows and about 20 columns corresponding to mortgage applications in Boston, USA. So if you imagine taking that spreadsheet and you inputting it into our new algorithm, then it will quite quickly select the model for you by, in particular, telling you whether each predictor is either having a zero effect or no effect, a linear effect or a nonlinear effect. So here are the 20 candidate predictors in black, and in the colored in the colors we have whether or not the predictor is chosen as having a linear effect In fact, a lot of them are binary, so they have to be linear. 0, or some of them, 2 of them end up having a nonlinear effect, and we'll look at those in a moment. So the summary for this example is that out of the 20 candidate predictors, we have quickly selected 5 as having a linear effect on mortgage application denial probability, 2 predictors as having a nonlinear effect, and we can throw away the other 13 as being irrelevant. So we'll have a quick look at the predictors that have a nonlinear effect. And this is a theme that's been going, with my research for a few decades now, where we use ideas such as cubic splines and penalization to, in a sort of nice way, allow for nonlinear effects to enter such models. And if you go back to, say, the 1980s, when generalized linear models were the main tool for analyzing, binary response data like this, they would have just, assumed that these effects were linear and not even like allow for the fact that it could be nonlinear. So that's what generalized additive models add beyond generalized linear models. And if this was a banking and finance talk, which it isn't, then we could try to understand why a predictor such as debt payment to income ratio has this interesting nonlinear shape. So I'm just going to give one slide from our upcoming paper corresponding to a simulation study that we've done where we've compared our new approach to generalized additive model selection to a few of the others that are around. And they're side-by-side box plots where lower means better. So I'll focus on this panel here. And we're looking at misclassification rate where the classes are linear, nonlinear, and 0, and whether the methodology gets it right or not. So this box plot says that, about 10% of the time it got it wrong, but the other 90% it classified correctly in terms of those 3 effect types. And this is our methodology based on Markov chain Monte Carlo, whereas this one does a bit worse because it's the faster scalable mean field variational Bayes approach. This is another method that's been around for about 8 or 9 years called spike slab GAN. That is a very good method, but it doesn't actually scale very well. And the one at the top is actually the Hastings student method, which is doing really poorly. And we're still trying to understand why. And we think it might be just due to some of the defaults not being quite right. And we're looking into that actually this week to try to work out how to make it perform better in a simulation study like this. But the plot that we're looking at now is actually just using their defaults. All right, so coming soon to a web page near you, our paper, Bayesian Generalized Additive Model Selection, including a fast variational option, by Virginia, he and myself. And so this is an example of statistical methodology being done here in my group in University of Technology, Sydney. And I've only got a few more things I want to say about it before we move to the software part. And the centerpiece of the paper is its algorithm listings. And there are a few things that I love more than developing algorithms and listing them. So this is the Markov chain Monte Carlo algorithm for generalized additive model selection that we've developed. And so this gives all the steps that you need to do. It tells you which distribution you need to draw from as you go through, tells you maybe when to stop it. And the other one is doing the variational Bayes algorithm. So this tells you all the things that you need to update. And these are some more of the updates. And you like cycle around these updates for a couple of hundred times. And that gives you your scalable variational Bayes based generalized additive model selection. All right, so the idea behind having those algorithm listings in our paper is that any statistical programmer, regardless of how they program, should be able to implement it if they feel like it. All right, so we just use like this generic algorithm notation. So whether you're into Python or Julia or Fortran or MATLAB, you can, after you like get everything debugged and so on, get the same sort of pictures and output that we had a few slides ago by implementing our algorithms. Now, the last programming language on the list, which is just simply the letter R, which probably this audience already know about, but I gave this talk 13 days ago and to some people that aren't even in stats, so I had to like just say that R is also a programming language. And my guess is that in 2021, this is the one that sort of deserves a star because it dominates I think, in terms of use in statistical analyses, both in terms of applied statistics, but also all the people around the world that are developing new statistical methodology are more likely to implement it in R and make it available in R compared to the other languages. So most of the rest of this lecture is going to be concerned with R, and I've never used Python or MATLAB or Julia, for example, so I can't really say too much about those. All right, so just a reminder about our new paper, Bayesian Generalized Additive Model Selection, including a fast variational option, which is coming soon to a web page near you. All right, so I'm just going to have a drink of water and you can read the current slide and reflect on what I've been saying up until now. All right, so there's more. We didn't just write a paper. We also wrote an R package that goes with the paper. So in the next month or two, we will release a package called Gamcell Bayes that implements the algorithms that we showed a few slides ago, and also does various like back-end things like graphics and predictions and summaries. Plus, for free, we'll throw in a vignette. And a vignette is, for those of you that aren't familiar with it, it's like a PDF file that you can add to an R package. And it has, I guess it just has advice about how to use the package. It works through various examples and talks about various, options for the functions of the package. And as of yesterday, this has gotten up to about 26 pages. I like vignettes because they don't get refereed, so you can just sort of write it and don't have to worry about dealing with referees. All right, so new statistical methodology done the easy way. Any R user will soon be able to download our package Gamcell Bayes from the internet, start an R session, set up the response data in a vector we'll call Y, set up the predictor data in matrices that we'll call X linear and X general, then type in about 3 or 4 lines of R code and sit back and marvel at their newly selected generalized additive model. So that's quite a bit easier than taking those 4 pages of algorithm listings and coding it yourself, and also having to do all the graphics and summaries yourself. But life was not always like this. So we're now going to have a bit of a history lesson where we go back and talk about like what was life like, you know. So we're now we're in the 3rd millennia. What was life like, say, back in the 2nd millennia when I was a student, in terms of R packaging and software dissemination. So we'll start in the year 0,000. So this is 2021 summers ago. And of course, back in the year 0,000, we had Caesar Augustus as the first emperor of Rome. And if you wanted to get around the various, you know, Roman Empire towns, it was handy to have a pair of sandals and maybe a donkey. And also back then in the year 0,000, if someone special had a birthday, then what better than a jar of frankincense or myrrh. And then we had the 1st millennium. Then we have 1,000 years later in the year 1000. So like, for example, towards the end of the 1st millennium, the Vikings figured out how to build boats that were good enough to make it from Europe to North America. And so in the year 1000, we had Eric the Red and his fellow Vikings setting up a colony in Greenland for the first time from Europe. And the throne in London, on which Elizabeth II is sitting on right now, so in the year 1000, that was being set on by Ethelred the Unready. But he needed to get ready because in about 66 years' time, there's going to be a big battle up the road in Hastings. So that was the year 1000. And after that, we had the 2nd millennium. And the year 2000 is one that I think a lot of the audience will remember, but if you're a millennial, you probably wouldn't know about, well, you wouldn't have been around to know about things like Sydney hosting the Summer Olympic Games. Or another big story in the year 2000 was Al Gore coming quite close to being the United States president, but probably missing out due to so-called butterfly ballots in Palm Beach County. So in the year 2000, we also had the comprehensive R archive network being officially launched on the 29th of February 2000. And the John M. Chambers Statistical Software Award having its first recipients. So these two very important events concerning statistical software dissemination both happened right at the dawn of the 3rd millennium. So there was sort of this sea change as we went from the 2nd millennium to the 3rd millennium. I'll just say a little bit about the 2nd millennium because that's when I was born, did all my education, and started my research career. In fact, around like the first 15 years of my research career took place back in the 2nd millennium. And so it was a different time. We didn't have the internet. Email was only just getting started, like around I didn't even start using email till around the late 1980s. And when I was doing my doctoral research in the mid-80s, we did have computer programming languages, but they weren't as friendly as ones like R. Graphics wasn't as easy. And the other thing is that we didn't really share our software very much. And if we did, it was fairly casual. All right, so now I'm going to talk about a paper that got published around 30 years ago. So this was my first paper in the Journal of the American Statistical Association. And despite my young looks, I wrote this around 30 years ago. And with two co-authors, Steve Marin and David Rupert. And I had forgotten a lot about this paper, but one thing I did remember when I was getting this talk ready is that it has an algorithm. So here's the algorithm from Wand et al., Jasson, 1991. And I'd forgotten a lot about this algorithm, and when I started going through it again, well, there are a few things that I found interesting. One was step 2, which is shows as a very rare example of an algorithm in a major stats journal where you have to raise a number to the power of 1/13. So don't raise what's in the curly brackets to 1/12 or 1/14. That would be wrong. Raising it to the 1/13 is what you need to make everything sweet, at least according to some asymptotics that we did back in the early 90s to justify that step. Now, if you wanted to implement this yourself, a lot of the steps are pretty easy. But for example, this one here about setting up this grid, that actually was quite a bit of work to do a good job that my co-author Steve Marin had to spend quite a bit of time on. So if you wanted to implement this as well as we did, I mean, to do a good job as well as we did to get a JASA paper out of it, it would be quite a lot of work. And as far as I know, not too many people have used the methodology as intended because we never packaged it. There was no such thing as the Comprehensive Archive Network in 1981. And I don't know if anybody has done it since that time. All right, so now I'm going to spend a few slides talking about what's it really like to write a dissemination-ready R package. So my answer in one sentence, and I should say this is just my personal experience. There's many thousands of people around the world writing R packages. But my personal experience is, in one sentence, that writing a dissemination-ready R package is very time-consuming, extremely tedious, but ultimately rewarding. All right, so now I'm going to go through my personal experiences in terms of writing R packages, which I've been doing since around 2010. And I'm even just finishing off one now that I've been working on and off for the last year. So for me, it's important to have a to-do list of all the things you can think of adding to the package and fixing things up with it. So I have this constantly changing to-do list that sometimes gets really quite big, but eventually towards the end of the package, diminishes down to zero. In the last few years, I've started using the GitHub version control system that I like, and it's also helpful to share that with my co-authors of the package. I've been using Unix my whole career, and I can't imagine personally not using Unix for package management, but I guess I'm fairly rare with that view. I tend to use I tend to have lots of simulation studies and that are attached with the methodology. And that's important, I think, to make sure that the package is durable to be able to handle lots of different settings. But then after doing that, it's also important to test it on actual data. And that tends to have lots of surprises that the simulated data might not have. A big one is hunting down bugs. So even 2 days ago, I spent the best part of one morning just finding one line of code that wasn't quite right and having to fix that up. And then there are things like having safeguards for invalid inputs. So if a user in the future puts in things that aren't quite right, trying to make sure that they get a warning or an error message to avoid things like going haywire. Another one is testing for boundary cases. So I do a lot of regression type methodology, and you might get things working fine when you have 30 or 40 predictors, like the package I just described. But if you have 0 or 1 predictors, then due to some peculiarities with R, things could crash at such a boundary case. So another big one is making the graphics professional, and that can take a lot of time to make it ready for an arbitrary user to use and be happy with what you're given them. And then another one that takes very many hours is documentation, which you have to do for an R package to describe how all the functions work and how to use them. With the vignettes that I tend to do with my packages, I use the software tools Weaver and Sweave. And in more recent times, it seems like you have to have a paper that goes with the package. So I don't know if I'm totally correct about this, but my impression is that you can't just submit a software package without having some document in the form of a paper, not necessarily published, but on the web somewhere like archive. So you have to write that as well. And then after doing all that, then you have a lot of fun making sure that it's compatible with the network. And then the last step is you have to then have it checked by these human beings that work with the comprehensive R archive network, that are like the gatekeepers for having it put on the network, and get it past them. And that can be a lot of fun as well. All right, so the next thing I thought I might do, just given that I'm really talking about my personal experience, which I guess has a lot of experience in terms of stats methodology papers, but only about 10 years worth of experience with R packages. And there are only 5 that I would say I'm the main programmer for. And there are about 3 or 4 others where I'm part of the package, but I wasn't the main programmer. So what I decided to do for this talk is give a rough estimate of the time to effort ratio, time slash effort ratio needed for a paper versus an R package. And the integer that I came up with was 2. So when I think about all the things that I need to do to get an R package ready and make it professional enough to share with the world on that network, I would say it's roughly twice as much work as how much I spend on a typical stats methodology paper. That's how much work's involved. So if I hadn't written those 5 R packages, then I might have time to write another roughly 10 papers, not some of my best stats methodology papers, but sort of like the average ones. So that's how much extra it takes to put out an R package. But this, of course, is just personal experience only. All right, so now we'll go to listing some of the pros and cons of packaging a statistical methodology paper. All right, so some of the pros that I thought of, the first one is quite an important one, and that is that if you can say when you submit a paper to a journal that there's an R package or another package from another language associated with it, then that should improve its chances of being accepted. So that's an extra positive aspect of the paper that will help it get accepted. The next one is one that you could argue is sort of obvious for people that spend a lot of time developing statistical methodology. You want people to use it, having spent all that time, and if there's an R package that goes with it, then it's going to be much more likely that it will be used. And then, of course, there's an extra thing that you can add to your CV if you have an R package on a place such as the Comprehensive R Archive Network that's gone through the vetting process for that. And the last one is that, yes, if there's an R package that goes with a published statistics methodology paper, then it's more likely that it would have gotten used and therefore cited. So later on, you'll probably have some more citations from that paper. So now we'll go through a list of cons. So the first one is that, yeah, as I said, if I'm spending twice as much on a package compared to a paper, then I'm going to have less papers. And I'm even on a performance bonus where the people that decide whether I should get the bonus or not count papers, maybe not so much R packages. So it could be costing me money to spend time on R packages compared to writing papers. And then for grant applications, a lot of us probably on this Zoom hookup know about writing grant applications for the Australian Research Council. There's a lot of paper counting that goes on with that, and not so much, as far as I know, in terms of R package, because one reason is, of course, that R packages are specific to our field of statistics, and we're competing against scientists from all different areas. All right, another one is, in my school and faculty, I've got superiors who aren't statisticians. And so it's not clear that they even know what an R package is. And so they, when they look at my performance, they look at things like the number of papers and grants that I'm getting and don't really know, or aren't really aware of the importance of, say, an R package. And then the last one is that, job offers and promotions and prizes and fellowships and the like tend to be more oriented towards papers rather than software products. All right, I'll just get a quick drink of water before we get to the next part. So then what I thought I would do is have a look at some of the list of winners of prizes in statistics. So this is probably the most prestigious one. This is sometimes called the Nobel Prize of Statistics, but it's officially called the Committee of Presidents of Statistical Societies Award. And it's given every year to an under 40-year-old statistician anywhere in the world. And these are the last 10 winners. And most of them have won it for work in theory and methodology. Although the 2019 winner, Hadley Wickham, he is an exception, I would say, because he's quite famous for his work involving statistical software. And the 2021 winner, the last winner, Jeffrey Leake, also seems like he's done quite a lot of software type contributions as well. Whereas most of the others, I think, are not so much noted for their software contributions, if they've done any at all. And then I went to the main award for the British Statistical Society, which is called the Royal Statistical Society. And this is the Gee Medal in gold. And these are the last 10 winners of that. And again, most of them, these are quite big names in statistics, such as C.R. Rao and Bradley Efron. And most of them, again, you would say they've been recognised for their theory and methodology. But then I remember that the last winner, David Spiegelhalter, he did actually help start the bug software for Bayesian inference based on Markov chain Monte Carlo. And bug stands for Bayesian inference using Gibbs sampling. And then John Nelder, who was one of the fathers of generalized linear models that started back in the early 1970s, he also helped start the software that helped, I guess, make generalized linear models more accessible, which is called GLIM. So yes, he was involved with software dissemination way back in the 70s and 80s. So he gets a green star from me as well. Top 10 publishers in the Annals of Statistics, Biometrica, JASA, and Journal of the Royal Statistical Society Series B. All right, so on this list, I don't know if any of them are involved in software dissemination in terms of R packages and the like. They're too busy writing their latest Annals or JASA paper. So this list is a bit on the frivolous side, but when I saw it, the first thing that struck me was that number 1 is my PhD supervisor, and number 2 is my first boss. So during the early years of my career, these two blokes used to make me feel quite small because how quickly they were able to churn out papers in major journals so quickly. But now I can see that when I saw this list compared to the rest of the whole field of statistics, I saw that they are actually quite special in that regard. All right, so how about recognition of statistical software dissemination? And when I first said I was going to give this talk, I didn't think there was such a list. But then I found the John M. Chambers Award list, which I did maybe know about a little bit in the back of my mind, but I wasn't quite on top of it. So I went and found the list of the last 10 winners of the John M. Chambers Award for Statistical Software. And yeah, so the 2019 winner, for example, was somebody that did the work when he was at Monash University, which is also part of the Centre of Excellence that I advertised on the first slide. Yeah, so this is a list now that is recognising since the year 2000, since the start of the millennium, novel statistical software contributions. Now, another thing that happened when I agreed to give this talk the first time 2 weeks ago for our Centre of Excellence, and when it first got advertised, the industry liaison person for the centre contacted me and told me about this entity called the Australian Research Data Commons. And this is one of their web pages that talks about a research software agenda for Australia and recognising research software as a first-class output of research. And so this is, a new initiative that that even there's somebody on my campus that I'm meeting in a couple of weeks from now, someone named Tom Honeyman, that is, recognising the importance of research. As research software for first-class research. All right, so one last topic. Who are the heroes and role models of software dissemination? And again, I'll say that most of this talk is on R because that's the language that I do my work in. So I'm sure that there are very important heroes and role models for, say, Python and Julia software dissemination, but I don't know who they are, so I'll thank them as well and acknowledge them. But because I don't use those languages, I'm not really sure who the main people are. So I'm going to give a couple of slides now on heroes and role models, but I do need to first issue a disclaimer. So this is just people who have caught my attention regarding work on R. And the list is very ad hoc and far from complete. All right, so this is just an ad hoc list. And if you're watching this talk and you think that you should have been on the list that's on the next slide, then I'm going to apologize to you right now because, I just, relatively quickly put a list together. I wanted to have at least one set of sort of people that I wanted to acknowledge, but then the danger is that I'm going to miss important people. So here's an ad hoc incomplete list of R heroes. All right, so we'll start with the first column. And these, except for the last name, these are Australians or Australian-based people. And so, so these people to various levels have been involved in software dissemination and R packaging. Two of them are at Monash University, which are Di Cook and Rob Hyman, also Emmy Tanaka. And these two professors of statistics there have been involved quite heavily in software dissemination in the last couple of decades or so. Now, the last row are New Zealanders. And New Zealand has actually played an important part in software dissemination. And if you hadn't heard anything about R before this, talk, and I know when I gave this talk a few weeks ago to a public lecture audience, there were probably quite a few people like this. And an interesting thing to ask is, where did R start? And someone who hadn't heard about R or didn't know much about it might think, it started in the San Francisco Bay Area or down the road in Silicon Valley, or maybe over on the east coast of the United States around New York, or maybe up in Toronto in Canada. Or did R start in Europe in a place like London or Paris or Berlin? And the answer is none of those places. R started in Auckland, in New Zealand. And in fact, Ross Ihaka and Robert Gentleman were colleagues at University of Auckland in the 90s. And they started R, and that's why it's called that particular letter of the alphabet. And so R is actually a New Zealand product from our cross Tasman cousins. And I have noticed that New Zealand tends to punch above its weight when it comes to software dissemination. All right, so then I decided to make a list of people that I'm grateful to, I guess, based on my areas of research, which are areas like non-parametric regression and additive models and generalized linear mixed models. So this list is biased towards, my work in those areas. And if you're a researcher in completely different areas of statistics, such as, say time series, or I don't know, social network analyses or whatever, then, I want to acknowledge your research as well, but I haven't really used it because I don't work in those areas. But these are the people that I'm grateful to for what I tend to do a lot of. So, for example, Dipan Saka has written this very, very nice package called Lattice that allows, very advanced graphics involving multiple panels and the like. And then, we talked earlier about generalized additive models, and people such as Trevor Hastie and Simon Wood have made them much, much more accessible because of their devotion to packages such as GAM, GAMCell, and MGCV. And then for mixed models, Doug Bates has done a huge amount of work to make those more accessible. And I also use RStan a lot, which is an interface for Markov chain Monte Carlo sampling. All right, so just to close off the talk tonight, so I'm going to talk about the 2019 War Memorial Lectures, and this is an annual lecture, which is probably the most prestigious one that's sponsored by the Institute of Mathematical Statistics. And the one that was delivered 2 years ago was given in person. Well, sorry, I attended in person because I went to the meetings in Denver, United States, known as the Joint Statistical Meetings, which I went to in person. This is actually the last one that was like normal before the pandemic. And I was pleased when I was looking through the program just after arriving at the meeting that my friend and one of my main role models, Trevor Hastie, was the 2019 Ward Memorial Lecturer. And I went along to them, and he obviously said many things, but one thing that he did say, that I'm going to now show you, is that he believes that it is very important to software package new statistical methodology, otherwise it tends to fade away. So after he said that, I decided to take it even more seriously, software packaging, and I've tried even harder to package my statistical methodological contributions. All right, so I prepared the abstract for this talk about 5 or 6 weeks ago. And then when I was finalizing the talk, I thought I'd better check to see whether the slides contained answers to all the things that I said I was going to talk about. So the one about R packaging, I think I did at least say a bit about that and give some answers. And then also I've given a few answers, even though they're a bit ad hoc, about heroes and role models. But then there's the one about reward systems, and I don't really feel like I've given any given any good answers about it. I've raised it as an issue, but yeah, I didn't really address it very well in terms of answers. Partly because I don't really have any good answers at the moment. When I gave the talk in the public lecture series for our Centre of Excellence 2 weeks ago, yeah, there were a few proposals that came up. One was about using counting systems for the Comprehensive Art Archive network, and one of my colleagues sent me a link that told me how to count the number of downloads that my packages have had. Then you sort of worry about whether that could be abused or not. Like, can you get your cousins and grandparents to download your R packages hundreds of times? So that's a concern that I thought about since then, but maybe there are ways to stop that sort of thing happening. Anyhow, I decided 2 weeks ago, and I guess today as well, that I won't say much more about the last one and maybe leave it something that we can have as part of the discussion. So I'll end the presentation here and pass back to Thomas to decide what we should do next.
Thank you, Matt, for a wonderful talk. And before we head into and to see whether any questions from the audience, I would like to make a pitch that the New South Wales branch is organizing a young stats and early career and student statisticians career events in the 1st of December. This is going to be a face-to-face event, and we have a fantastic line of speakers. And if you are free and available, please check out this event. I just post the link in the chat. Then it's subsidized. If you're a member of ours, it's totally free. So hopefully we can entice a few of you to turn up to that event soon. And I'd love to see everybody to turn up. And of course, the early career and student, the early career definition is we're going to be vague. If you think that you're young at heart, you can join us as well. And please join me to thank Matt for a wonderful talk. I think this is a topic that I find quite fascinated about and always have keen. And also, I'm surprised to find that Matt also takes so much time to write our package into a proper format.
Okay, you think I'm a bit on the slow side?
No. I'm just saying that it just highlight that it indeed took a lot of time and effort to create an R package to a proper standard.
Okay, I thought you were saying that you're much faster than me at writing R package.
No. I can relate that sentiment. It also took me a lot of time to do that.
Yeah.
Anyway, do you have any question from the audience for Matt? Okay, in that case, I'll ask the questions. Regarding the reward systems, and I think we both agree that it took so much time and effort to create an R package into a right standard for end user to use, instead of program them everything themselves. How can we change the reward system, or is there any way we can make this easier for us?
Yeah, that's the thing. I said I don't have any good answers for yet, so I was hoping someone else might have good answers.
Okay, maybe I phrase it the other way. Would it be better to actually in our degree to actually have software development as part of the curriculum?
Yeah, I definitely agree about that. If you can fit it in amongst all the other things that we've got to teach our stats students. But yeah, I think the earlier that young statisticians start using languages such as R, the better. Like even from first year stats, and particularly programming, not just using the menus, but actually writing for loops and the like, and functions. So yes, I definitely agree about that. Whether we can
continue, Matt.
Yeah, whether we can fit something like R package into a curriculum, I'm not sure. That sounds quite hard, given all the other things that have to be fitted in. And
we have a question in the chat from Mark. It seems like MinPack is a desirable thing to describe the promotion and grant committees. surely software downloads would something that they considered.
Yeah, I'm sure they help. I mean, my question back to Mark is like, is it abuse proof for things like download statistics and data? Like, can you, I don't know. I mean, you hear about like click farms and so on. Like, can you sort of make sure that it's done in a, you know, like non-abuse way? Well, like with citations, I can't get my my parents to like cite my papers because it would take them too long to write a statistics paper. But with a download, yeah, I can get my parents to download all my packages every couple of days.
Hi, it's Mark here.
Yeah. Yes, hi Mark.
Hi. So I'm a Stata user, and I sometimes see people in their Stata commands saying, please cite my methods paper if you're using this command. So that's one way you can help improve, you know, your CV, I suppose, with citations anyway. Stata monitors, well, there's a website called Econ Papers, which allows downloads to be assessed over time, but I can't imagine any committee is going to go into the details and have a look at that. But that could red flag everyone downloading it 1 month and never afterwards. But
so I think I've seen some R packages that also encourage you to cite it, and I think you can even like add a function called citation or something similar to help the citation aspect of the package.
I think we also have to get into the practice of citing the R package we used in our paper writing. I don't think that's something that we do consistently.
Yeah. So then if you do cite it, then does that get counted by things like the Web of Science? Like the Web of Science looks at journal, you know, if you have a journal article that gets cited, that'll get captured by that, but I don't know whether if you have an R package that gets cited, whether that'll get captured, and probably not for the Web of Science, but maybe some of the other ones like Google Scholar. Yeah, so that's something that's probably there's still room for improvement on as well. Recognizing citations of R packages or other software products.
And Alex in the chat also mentioned something about GitHub repo dependency.
Yeah, I don't, even though I use GitHub, I use GitHub, but I only know about 4 commands, so I don't really even know what that means actually. But, yeah, I think that did come up when I gave the talk 2 weeks ago.
so again, I'm not sure about the R perspective, but Stata has a journal called the Stata Journal, and like if you've written your vignette, which we call the help file, you could also write up a paper, which I think you described, and sort of attaching it for free. But so what I'm doing at the moment is writing up a paper related to my command and help file, which I hope will get published in the Stata Journal, and that gets linked to well, at least Google Scholar and possibly PubMed, I'm not sure. And in fact,
so there's also the R journal.
There's what, sorry?
So just like there's the Stata Journal, there's also the R journal, which has the similar idea.
Yeah.
And that does get captured by the Web of Science.
So would you because it's always extra effort, isn't it, to go the extra mile and try and get it in one of these places. But
yeah, so I'll tell you a bit about my experience with that. So I still haven't submitted to the R Journal, but there's another one called the Journal of Statistical Software.
yes,
And I have been publishing there since it started around the early or mid 2000s. But I don't want to say publicly what I think of the journal these days compared to how it was back in the 2000s. So I haven't found it as good in recent times. But I haven't tried the R Journal, and I do intend to try that in the future with my vignette type things.
Yeah, I mean, one of my most published papers, or most cited papers, sorry, is one in the Stata Journal.
Yeah, and what happens when you look at the citation counts for statistics journals, then those software ones do tend to do very well. But the statistical software journal is one of the highest in the whole field now.
Yeah, yeah.
It sort of shows that how people are, reading those articles and using them and citing them, compared to like a typical theory and methods paper.
All right. Thank you, Matt, and thank you, Mark, for the discussion. I think this is all the time we have this evening. Please join me once again to thank Max for a wonderful talk this evening. And if you are, feel free to hang around and actually have a chat. Everyone can unmute themselves and have a chat. And if you want, you can continue this discussion with Matt. Otherwise, enjoy the rest of the evening.